All right, today we're going to be looking at this idea of Newton's law of cooling, which is the idea that you've probably used plenty of times if you've ever pulled something hot off the stove or taken something out of the oven or even something hot out of the microwave. Um, how long does something take to cool down? What factors affect how things cool off? But we needed a couple tools, some math tools, in order to figure this out. The first thing that you're going to need to know is we're going to be using this number e, and e is a number that's like pi. It's just a constant. It's an irrational number, so this is like just like pi. Kind of the decimals go on forever. E is the same way, so we approximate e to be a number that's 2.718, and that's what we'll use when we use it in the problem. The other thing that we need to look at is this idea of natural log. So when we use the log before, log is basically asking the question, if we know a base and we know what the number is supposed to be when we raise that base to an exponent, um, what's the exponent? So all a natural log is a log with a base e. Okay, that's a natural log. And sometimes you see that as ln, shortened for ln, but it means natural log, and you can also rewrite it as log base e if that makes more sense to you. So we want to know the relationship between natural log and e, and that relationship is that they cancel each other out. So if you have a e in a problem, let's say e is on one side of the equal sign. If you raise both sides, if you take the natural log of both sides of an equation, so let's say for some reason e equals 2. If you took the natural log of e and the natural log of 2, this would get canceled out. And let's say maybe it's e to like the x power. Then x would be on one side, the left side of the equal sign, and the natural log of 2, which you could find on a calculator, would equal some number. So we're going to use that idea that we can cancel out e with a natural log when we solve these problems today. So Newton's law of cooling has some different variables we need to keep track of. One is T, in this case TO. That's the initial temperature or starting temperature of a substance. Then there's TR, which is the room temperature, or the environment temperature if it happens to be not in a room. R is the cooling rate, and that really depends on what the substance is that we're using in the problem. T is time measured in minutes. And this other T that's on the left-hand side of this equal sign is the measured temperature after cooling. So let's say we pulled something out of the oven, it's 350 degrees, maybe the room is 70 degrees. We measure the temperature 20 minutes later. That would be our measured temperature after cooling. Sometimes this is the temperature that we want it to be. Like let's say we want the temperature to be 200 degrees and we're trying to find out how long we have to wait. But that's where that number would go. So let's look at the first example. If we're cooking a stew, when you take the stew off the stove, its temperature is 212 degrees Fahrenheit. The room temperature is 70 degrees, and the cooling rate of the stew is 0.046. How long will it take the stew to cool? How long will it take to cool the stew to a serving temperature of 100 degrees Fahrenheit? We're going to take 100 here. 100 is the temperature that we want it to be. That's going to go on the left. 100 equals TO is going to be our initial temperature. So that's 212. And we're subtracting from that 70 degrees. And then we have E to the negative R. So R is 0.046 times time, which we don't know. and then we're adding to that TR again. So we're using TR twice. All right, so we can simplify. First thing that I might want to do is subtract 70 from both sides. It's going to give me 30 over here. 30 equals 212 minus 70, be 142, times e to the negative 0.046 t power. We divide both sides by 142. And we have a calculator that we can do that with. 30 divided by 142 is 0.211. I'm just going to solve that down here. Forget about this problem for the moment. 0.211 equals e to the negative 0.046 t power. All right, so here's where this move that we have to do comes in. So we have to take both the natural log of both sides. So we're going to take the natural log of this, okay, the natural log of 0.211, which is negative 1.56. And that equals, if we take the natural log of this side, that cancels out that e. And it brings this exponent down. So now the problem is negative 1.56 equals negative 0.046t. And the only thing left to do is just divide both sides by negative 0.046 to find out our time. We want to get time by itself. Negative 1.56 divided by negative 0.046 equals t equals 33.9. So just about 34 minutes. So in our problem, if we take our stew off the stove, it will take about 34 minutes to drop to our serving temperature of 100 degrees. That's how it's done.